Hello everyone, I welcome you all to today's session, a pathway to continuous integration and continuous delivery on AWS, brought to you by Reskill program. A quick introduction about myself. This is Bhuvaneswari Subramanian here. I work for Infor as Director of Engineering Operations. I'm also an AWS DevTools hero from India, and we would like to present this Reskill program as part of AWS User Group India and several other AWS user groups across India, organized in multiple cities. In this particular session, I'm going to take you through a pathway to continuous integration and continuous delivery, a quick overview of AWS developer tools. We're going to talk about a simple use case leveraging AWS developer tools, which contributes towards setting up continuous integration and continuous delivery, and the best practices for configuring CI/CD, and we are also going to see the metrics to gauge continuous delivery. First, a pathway to continuous integration and continuous delivery. So what you see here is 4 stages: source, build, staging, and production. Whatever may be the software development methodology that we follow, be it feature-driven or agile development methodology, the source code that is developed by your developers, they might be spread across several countries and cities. All of that code should be collaborated by keeping them in a central repository. That's where the source stage comes into picture. And the source, whatever have been collaborated, developed by a bunch of developers, have to be built, and an artifact should be generated, and it should be deployed to a staging environment, shared it for testing with the quality assurance team, and also you can run wide variety of test suites like performance testing, integration testing, functional validation, security testing, all that, followed by finally, with approval from the release manager, we all should be set to take it to the production environment. So in a nutshell, whatever is committed to the source control system should be always ready to be deployed into the production environment. How can you ensure that the code committed is ready for deployment at any point in time? So this means that at every stage, you need to have complete automation in place, which will establish a standard and ensure that when you move from one stage to the other stage, quality is met. So each stage acts as a gate so that the code gets matured over and over. Finally, when it moves to the production, it will be absolutely error-free. So that is our ultimate goal. So when we are talking about this path to continuous integration and continuous delivery, what are the tools from AWS Cloud which would fit into these different stages? So we have AWS CodeCommit. This is to have the source control in a central place. You can have the peer review done. You can have multiple branches created, and developers can collaborate separately for the separate feature they are working on. And you can have an integration branch. You can strategize and maintain the way your business would need. And we have AWS CodeBuild, which is going to help you with compiling the source code, generate the artifact, and store it in the S3 bucket. Also, you can run unit tests, static code checks, all that can be done as part of AWS CodeBuild. And the next one is AWS CodeDeploy, which you can leverage to deploy to either on-premise or EC2 instance. And you can integrate with wide variety of third-party tools for your testing needs. And finally, when you wanted to take the changes to the production, it's again AWS CodeDeploy, which can help you with the deployment to that. And we also have AWS Code Pipeline, which can link all these different tools together, glue them together, give you a good experience where the source changes can be taken to the production. So now let's see how all these tools can be leveraged to set up your continuous integration and continuous delivery. So as part of this step, the first thing what we will do is setting up the continuous integration. So we have application developers. When they work on the application changes, they would commit their code changes into the code commit repository. And whatever the changes that is committed, we have to configure the pipeline so that the code is compiled, artifact is generated, and it is all set for the deployment. So when you're setting this continuous integration, we will have to ensure that the developer commit the changes to the central branch or the release branch as often as he could. This could avoid a lot of surprises in terms of issues later on. If at all they feel any feature that needs to be lived long apart from the release branch, they have to ensure that the changes from the upstream branches are merged to the feature branch quite often so that they don't miss out other feature changes which has gone into the release branch. So remember, the first person who commits his changes into the release branch will have less issues to deal with compared to the one who commits their changes later in the cycle. Okay? So the important thing to remember is you have to commit your code changes quite often to the central repository so that you're in sync with the other folks who are parallelly working on required features for your product. So now once you have established the continuous integration in place, that is every commit your code changes are compiled, ensuring that it is error-free. Okay, first job done. What is next? When we have the compilation done, artifact generated, it's ready, we need to deploy to the staging environment, get it validated. Either you can share it with the bunch of testers who would manually validate, plus you can run wide variety of test suites. It could be your load runner for performance testing, JMeter for performance testing, or you can run your security testing suites. It could be your UFT functional validation. You're free to run any kind of testing that is required by your product on the staging environment. Most often, if you wanted to do exhaustive testing, the staging environment will be created similar to the production stack. How could you create the staging environment? You can either deploy the application on the pre-prepared environment, or you can also create the staging environment using infrastructure as a code. It could be using AWS CloudFormation template, or it could be with Elastic Beanstalk, or you can leverage OpsWorks. You can also go for Terraform to create the infrastructure and then have the application code deployed on top of the newly built infrastructure. Okay, so remember the staging environment. You can prepare the staging environment by deploying the newly generated artifact on a pre-prepared environment or on an environment which is purpose built for this particular staging environment and for validation. So now that we have staging environment created, application is deployed and validated, we are set for production rollout, right? So the next step is continuous delivery. You have to establish the continuous delivery pipeline to take the code changes to your production environment. How could you do that? It's again when you have leveraged the infrastructure as a code. It could be a CloudFormation template or Elastic Beanstalk or OpsWorks. Now you have tried and tested infrastructure code as well as application code successfully working on the staging environment. With this, creating the production environment is also going to be seamless for you. Once the infrastructure is created, and then you can leverage AWS CodeDeploy to deploy the application which is already validated in the staging environment and production ready. So delivery to the production environment or deployment to the production environment, you can again leverage these services, CloudFormation template. Obviously, CodeDeploy, we need to deploy applications, and Elastic Beanstalk or OpsWorks. So now we did the continuous integration where the source changes are built and artifact is created, and we have deployed onto the staging environment. Finally, after validation, we have also created production environment, deployed the code. So now this should continue, right? We have to aim for continuous deployment to a production environment. That's the ultimate goal. This will help us to take the changes from the source control system to the production environment for faster than ever. So with continuous delivery pipeline, you can establish that using AWS Code Pipeline. If you see here, we have AWS CodeCommit, which is symbolizing the source control system. Later, your AWS code build is what have been helping for compilation and also running the unit test as needed. Later, deploying to the staging environment, you can leverage AWS CodeDeploy. And finally, to take the code changes to production environment, it's again the CodeDeploy. So now our continuous deployment is in place. So let's move on to see what are the different teams that were involved when we're trying to implement the CI/CD. First and foremost, we know we want the application team, of course, to develop the application that is required. That is our core business, right? So the application team is responsible for working on the applications. And remember, they are not going to work on any non-core stuff. Their goal is only to work on the application changes. And then I'm going to focus on how the infrastructure will be built and how the automation will be established to take the changes to production. So their focus is only on application development. Next is infrastructure team. This team could be relatively smaller compared to your application development team. So their goal is to work on the code changes that is required to take the infrastructure to the production environment. So when we are trying to establish this code changes, so they could work on an infrastructure as a code. They would also version control their infrastructure code similar to the application code, but it could be always maintained in a separate dedicated repository. So we can separate application code as well as infrastructure code and maintain them in two different repositories. So now coming back to the third team, it could be tooling team, or it can be represented or called by different names based on the company. So they are responsible for setting up your CI/CD process and also develop the tooling that is going to facilitate both application developers and infrastructure developers to contribute towards this CI/CD process. Okay, so these are the three teams who are going to be part of your continuous integration and continuous delivery path. Now, let's have a closer look at AWS developer tools which contributed to set up the continuous integration and continuous delivery. The first one is AWS CodeCommit. So this, when we are talking about the AWS developer tools, we're going to discuss about CodeCommit, CodeBuild, CodeDeploy, Code Pipeline, right? So all these services are managed services. Building the server, ensuring high availability, and ensuring that it is scalable, elastic in nature, all that is off your shoulders. When you talk about managed services, it is taken by the cloud provider itself. So with all these services that we're going to talk about as AWS developer tools, so they are fully managed servers where you are free to focus on your business and innovating further, where all these servers that is required to facilitate run this entire continuous integration and continuous deployment are taken care by the cloud provider, that is Amazon Web Services here. So coming back to AWS CodeCommit, so if you know Git already. If you've been playing around with Git using your Bitbucket, GitLab, or GitHub, so that means you know 90% of code commit, right? It's relatively simple. So the most important thing is it's scalable, secured, and managed service. And how can you interact with code commit? You can use AWS console, or you can use any of the command line tools that you traditionally use with Git. So the most often asked question is, can I migrate from other source control system to AWS CodeCommit? Yes, you can do it, provided if it is Git, it is pretty straightforward. Otherwise, if you're trying to migrate from any other services, first move to Git and then move to CodeCommit, which can be done seamlessly. So coming back to CodeCommit, it has all the goodness of scalability, availability, and durability of Amazon S3 and DynamoDB. That's why we say it's a highly available and reliable service, because we know that there is no limit on what you can store on Amazon S3 and how much data you can put it into the DynamoDB, right? Since this service is completely backed by Amazon S3 and DynamoDB, there is no limit on that. Further, I would like to reiterate that there is no limit on the number of repositories that you can create here, and also what could be the size of the repository. There is no limit on that as well. Okay, so you can have post commit hooks to call out SNS and Lambda, and also remember you can enable notification to be sent to the committers when a commit is sent to the specific branch. So you can send notification to the users in different ways. Okay, so now moving on to the comparison with the current services. So if you see CodeCommit as a service, it has all the goodness of your traditional source control system. It has a very good visualizer where you can compare and contrast the flow, how it moves with at least the max of 35 branches together. And you'll be able to compare between two commits, obviously. And you can raise a pull request, get it reviewed and approved by your peer or superior. So all these things can be very well done with your AWS console also. Okay, and creating this code commit, you can create it from console or your command line interface. You can also create it using CloudFormation template. Okay. Now code build. So we have a place to store the source control where we are talking about code commit. Once that is ready, so we need to take that source control code which is committed and build them and generate the artifact which is ready for deployment. So AWS CodeBuild is the service from AWS Cloud, which is again a fully managed build service that can help you to compile the code, generate the artifact, and optionally run the unit tests as needed. So it is highly scalable. How do you say it is highly scalable? For example, if you have set up a build against one specific branch, it could be your feature branch or a release branch. If the branch has to be run continuously and parallelly by many people, for each of the build invocation, it is going to create one container instance and run your build. So since for each of the invocation, it's going to spin up a dedicated container instance and then run the build against it, one build performance is not determined or impacted by the other build. So they all can run parallelly very well, and you can just move forward seamlessly. Okay, so you can also provide custom build environments suited for your build needs. For example, CodeBuild itself supports wide variety of operating systems and languages. For example, if you have Java, Python, all these are supported. In case some newer version support is not immediately available and you wanted to work on that, you are free to do that. So AWS documentation has the link to download the container instance. You can download it and make the required changes, and you can upload either to the ECR or to the other container hub and then start using it. So how you would make a payment for this? What are the different variants available? By default, you have small, medium, and large type of instances for your code build. You can choose either of them and use it. And how you're going to pay it? You're going to pay only for the number of build minutes you have consumed this. Okay. So if the project you have created and kept aside, but the build is not running, you're not going to pay for it. And this code build, you can launch it with AWS Code Pipeline or even with Jenkins. Okay. So when you wanted to create a code build project, what are things that you have to keep in mind? What informations you should be ready with? One thing is where to get the source code. You need to specify the source control repository. It could be your GitHub or it could be CodeCommit. So you have to choose the source control provider and you will have to choose the repository, branch, all that information. So basically where to get the source code from, you're going to specify it. Then you're going to choose the build environment, whether your OS is Windows or Linux. Is it for Java or .NET? You would choose and then move on to choose the S3 bucket where you wanted to store the artifact. And finally, and the most important step which you should not overlook is to store the logs. So you have to choose either S3 or CloudWatch to store your logs. You can store it in both. That's not a problem. But ensure you store the logs either in S3 or CloudWatch so that after the build is done, you should have a place to go and view the logs. Okay. So now that we have created the code build project, we will move on to code deploy. How this code deploy is built and how it's going to help us. Again, AWS Code Deploy is yet another fully managed service from AWS Cloud. It helps you to automate your code deployment either to EC2 instance or an on-premise instance or Lambda. So when you set up and configure the deployment for one EC2 instance, then deploying to hundreds and thousands of EC2 instances off your shoulders. That complexity is transferred from your shoulders to AWS Cloud. This AWS Code Deploy is going to take care of it. Okay, I have an EC2 instance. How can this EC2 instance become something which will be deployed through AWS Code Deploy? So for Code Deploy to deploy the application onto the EC2 instance, you have to first install Code Deploy agent. So when you have installed the Code Deploy agent on this EC2 instance, the Code Deploy can connect to that EC2 and deploy your application. Okay. So with Code Deploy, you can have minimal downtime. Further, it has an option to roll back automatically. So how does the rollback work with AWS Code Deploy? With Code Deploy, the rollback means the previously successfully deployed artifact is stored. So whenever there is an issue in the current deployment, it's going to roll back and point to the previously deployed one. So that's going to be quick. And this is going to support again wide variety of languages and operating systems. You can integrate with third-party tools like Jenkins, and of course it works very well with Code Pipeline, right? So even for the code build or for code deploy, I told that it can be integrated with Jenkins. How could you do that? So you can do that using corresponding plugins. We have a plugin for AWS Code Build and we have a plugin again for AWS Code Deploy. So once you have the Jenkins instance up and running, you're going to install these two plugins, configure them. So to configure these two plugins, you can actually have the access key and the security key configured while integrating it so that the code build will be able to connect to your AWS account, leverage that, and then run your builds. Remember, you're going to have only Jenkins master. You don't have to have the build nodes built. Either locally or on AWS cloud, you're not spinning up an EC2 instance or you're not leveraging the existing virtual machine. Here, if you integrate with AWS CodeBuild plugin, that's going to connect your AWS account, spin up, and then compile your code, generate the artifact. Yeah, of course, you can save it in your S3 bucket. So like that, see why these integrations are there in first place. You've been working on a data center world and you're trying to migrate to AWS cloud. So in this journey towards cloud, you cannot migrate things overnight, right? You might wanted to do it in a phased manner. So when you wanted to do it in a phased manner, first you might set up CodeCommit directly on AWS cloud, and you might want to have code build also, but you wanted to continue the deployment locally, and you can still want to use Jenkins for your integration or the entire continuous integration and continuous delivery. The reason could be your UFT integration, your load runner or JMeter performance testing integrations are tightly integrated with Jenkins, which is already running in the data center. That is not yet moved to AWS cloud. So when you have things in this kind of mix, it's called hybrid cloud. So you can integrate code deploy, code build with Jenkins. Okay. Okay. So what are the components of code deploy? First, when you're trying to create a code deploy project, you need to have the application which you wanted to deploy. There could be several applications you are planning to deploy, and the revision also plays a vital role, right? What revision that you want to deploy. And the side is you need deployment group. This deployment group, it could be a group of EC2 instance or it could be a group of on-premise instances to which this particular application revision has to be deployed. Okay, so basically when we are talking this portion constitutes what to deploy, that is your application, and your deployment group is all about where to deploy. So now you have what to deploy and where to deploy. How would you do this deployment? So to do the deployment strategy is more important. We have two different deployment strategies. One is in-place deployment. The other one is blue-green deployment. In case of in-place deployment, you're going to the specific existing EC2 instances, bring down the services. It could be your Tomcat service or Apache service that you wanted to bring down, deploy your application and bring up the service. This is happening on the existing infrastructure, existing EC2 instance. Whereas when we talk about blue-green deployment, you have the blue version running, serving the current traffic and holding on the current application version. Whereas if you have a new version ready, you're going to spin up all new infrastructure parallel to this blue stack and you're going to call it as a green. Have the application, that is newer version of the application deployed onto it, get it quickly validated. And when you are ready to go live with a newer version, it's at the DNS cutover away. You're going to make the ELB or your Route 53 point back to this particular newer version of the code and it's all fine. What if the new version has issue? You can turn back again to the current version, let it safely run until you sort out the issue with the newer version. So that's how the blue-green deployment works. Okay, so how does the deployment happens? That is with abstract.yaml file, which is heart and soul of your deployment, and we have deployment configs. So what does this abstract.yaml file carries? It basically carries your files that you need to copy it for your deployment. That is from where you have to copy it to where, the source and target. And it will have the hooks which will have scripts that need to be executed as part of the deployment. So now coming back to the deployment config, it's going to specify how the user experience should be. Should we bring down the entire application by having a specified downtime? It could be your 10 minutes or 20 minutes downtime as per your SLA that is defined with the customers. So based on that, this deployment config can be configured. So what options do you have here basically? So you can deploy one server at a time or half of the servers at a time, or all at once. So we have 3 different configurations based on which you can do the deployment. So basically all that matters when we talk about code deploy is what do you want to deploy and where you want to deploy and how are you going to deploy it, right? So we'll move on to code pipeline. So when you have the code commit repository created, code build project ready, and code deployment configured for the group of instances, now this creating the code pipeline is a seamless thing through which you're just going to model and visualize how your CI/CD pipeline is going to be. So this code pipeline is a continuous delivery service which is going to help you to make your source changes move all through these phases and reach production faster. So using this code pipeline, you can configure build, test, and deployment of your code suite. Remember, this can be integrated with third-party tools. So what is the need to integrate code pipeline with different third-party tools? In case if you wanted to your existing JUnit test or existing performance test, which is already integrated with any of the services, with code pipeline. Okay. So as part of this pipeline, you can even introduce manual approval stage where you can wait for your release manager to actually come and give a green signal for you to proceed with your release. Okay. So what are the different stages here? So now we will look into AWS Code Pipeline Components. So with this, you have stages, actions, and transition from one stage to another. For example, if you have a source control system, could be CodeCommit or GitHub, when you want to pull the source code from the source control repository, you will have a stage. That could be a source stage. Next, you wanted to compile that source code, generate the artifact. That's going to be a build stage. And you wanted to deploy to a staging environment, or you wanted to have a manual approval, or you wanted to deploy to production environment. These are all again different stages. So in each stage, you can have multiple actions. This actions could be executed in parallel or it could be executed sequentially based on your need. For example, in source stage, if you wanted to check out the code from 2 different repositories, for example, one from the application repository, the other one from the infrastructure code repository, you need to create 2 actions. From source to build, if you are moving it, you will pass some intermediate artifact from source stage to the build. So that phase is called transition. In between the source and the build stage that we are talking about, that source code which is pulled out have to be stored temporarily. That's again going to be a S3 bucket, which is independent from your S3 bucket where the artifact is going to be stored. So action, it could be like getting the source code from the source control repository or compiling the source code, or when you wanted to invoke a code deploy action to deploy. So these are all different actions. So a quick look at pricing. So if you are planning to play around with these services as your learner, or later you wanted to experiment before you wanted to take it live, so these are the things that you will have to really keep in mind, which will help you to quick start. So when coming back to code commit, of course, as part of free tier, you have 5 active users per month for free, beyond which you will have to pay $1 per additional active user per month. Beyond your free tier limit, beyond that 12 months period also, you will be able to leverage this for your code commit and make use of it. And coming back to AWS code build, you're going to pay only for the number of build minutes your compute resources are being used. And for code deploy, there is no additional charge when you're trying to deploy to an EC2 instance. You're going to pay only for the EC2 instance which is running, but definitely not for the code deploy project which you're using to deploy to the bunch of EC2 instances. Okay. But however, when you're trying to deploy to on-premise instances, there is a small fees around it. And remember, for this code build or code deploy, if you have created a project and if it is lying there, it's not going to charge you. It's similar to your Lambda function. If you create and just leave it, if it is a small function, it's not going to cost you at all. And if you put the code in S3 bucket, you're going to pay for the S3 bucket charge. And coming back to your code pipeline, again, you're going to pay only for what you use. That is one active pipeline per month. It's going to cost you $1. If you're creating a pipeline and trying it for a couple of days and you're going to delete it, it's not going to be charged. So this means that nothing is stopping you from learn these tools, and also try to do a POC so that you can take it as part of your projects in future. Okay, now let's come back to a use case. We're going to see the web application deployment to a pre-created EC2 instance. So we are using in-place deployment to an EC2 instance. Basically, what does happen in the deployment? It's going to see if the Tomcat service exists. If not, install it. If it exists, we're going to stop the service, deploy the web application, and start the Tomcat service. So here is the workflow for your web application deployment. Remember, since it's the pre-created EC2 instance, we are talking only about the application developer, and you could also have a tooling team who's responsible for this orchestration. Okay, there is no infrastructure developer here because we are deploying it on a pre-created EC2 instance. So your application developer have created the application. The code is committed into the code commit repository. In this source stage, we're going to check out the code. And in the build stage, using AWS CodeBuild, the source code is compiled, an artifact is generated and stored in the S3 bucket. So as part of code deploy, this artifact is pulled and then deployed into the existing EC2 instance. So our pipeline here is a 3-stage pipeline with one action in each of the 3 stages. Okay, so one correction here. Probably 2 actions we can say in build stage because it is optional for you to run the unit test. So you have the build which is going to create the artifact and store it. I'm having one more action which is going to run it. Okay, so in these 3 stages, here one action, here 2 actions. These 2 actions can run in parallel or sequential, however you configure. And third stage has one action which is going to deploy it. So this is our pipeline. So here EC2 instance, it is available within RBPC in a public subnet. This simple application, when it is deployed, it can be accessed by the external users through the internet gateway. So with this web application deployment, when you implement through the pipeline, how would the output look like? Okay, if all goes well and green, you would be able to see the commit ID based on which it is pulled from the source control system. Here it is code commit. Later, if the build is successful, you will see this succeeded message. And first I'm deploying only to the staging environment. So this is the 3-stage pipeline which we recently implemented. Okay, so what are the best practices and metrics when we are talking about continuous integration and continuous deployment? First, let's look into the best practices for continuous integration and continuous deployment. See, treat your infrastructure also as a code. Version control, get the peer review done, all that similar to your application code. So it's easier to spin up the infrastructure and have the application deployed. And have all the developers commit the code to the main trunk frequently with no long running feature branches. If at all your feature branch has to run for a specified amount of time, ensure that the feature branch gets the changes from your long running central branches quite often. It could be from your integration branch or alpha branch, so that your feature branch gets the required changes as often. And have the developers build unit test with 100% coverages so that all of your commits or the application features that is being developed are validated. before even it gets deployed into the staging environment. Established role-based security controls. For example, if it is infrastructure code, only infrastructure team will be able to commit, but it could be viewable by other application developers also. And for application code, it's purely application developer friendly. Like that, you create role-based security controls and keep track of metrics, monitor it to find the deviations and notify the stakeholders as quickly as possible. Okay. Also, treat your continuous delivery configuration also as a code. Now you have your pipeline, you have your code deploy, code build project, all that. Remember, if you're creating a pipeline, it's good to create the pipeline per branch, per environment, so different branches, different pipelines when you have. So if that is also automated, spinning up your pipeline is also automated, then if it is also stored as a code, then provisioning the resources and using them, it's going to be error free. And so that's the best practice for your continuous integration and continuous delivery. With this, let's see when the continuous integration and continuous delivery is implemented, how would you gauge whatever you have implemented have reaped the benefits? Okay, whether your ROI is good. So how would you gauge that? When you have rapid delivery with increased efficiency, that is, with a given time, if you're able to deliver more number of features to your production environment, that's a success, right? So increased features with reduced time to the market. And having the quicker feedback systems to your users and systems, it's going to be helpful. And greater percentage of defects detected in testing, unit and SIT cycles, it's going to have lesser defects in your pre-production and production environment. That's the end goal for us, right? And with the managed services like CodeCommit, CodeBuild, CodeDeploy, and CodePipeline, you are by default establishing the high availability, and of course elasticity and scalability is also there for the infrastructure. So these are the some of the metrics with which you would gauge, okay, I've successfully rolled out continuous integration, am I good? So these are the parameters just going to help you assess, am I right in the path of this continuous integration journey. Okay. So happy learning. Please do keep visiting Reskill program to update yourself. Thank you so much.